Hello friends, my name is Dhiraj Mahajan. Welcome to our channel, that is Mahajan Coaching Classes. So we are studying electric resonance from the AC circuit. Clear? Okay. So मैंने पहली बार अपना नाम बताया अपने चैनल के ऊपर. Okay. ऐसा इसके पहले कभी हुआ नहीं. Okay. इलेक्ट्रिक रेजोनेंस में एक अभी प्रीवियस वाला आप लोगों ने वीडियो देखेंगे. So we get the series resonance. So second type of electric resonance, so that is called as parallel resonance. Now second. So that is parallel resonance. So what is a parallel resonance and what are the conditions for parallel resonance? What are the equations of parallel resonance? What are the characteristics of parallel resonance? What is the graphical representation of parallel resonance? And what are the fundamentals of parallel resonance? So we are seen in this video. Now see, what is parallel resonance? Parallel resonance में नाम ही सजेस्ट करता है कि भैया हम लोग को electrical appliances, that means inductor and capacitor and resistance, we are connected in parallel, but we are not taking here in resistance. Why we are not taking resistance here? Because in resistance the phase difference between EMF and current is zero. EMF और current के बीच में जो phase difference होता है, that's phase difference is zero. So that's why we are not taking the resistance which is in parallel connection. Now this is pure inductor of inductance and ideal capacitor, that is C, are connected in parallel, and this parallel combination is connected across the alternating source of EMF, that is E is equals to E naught sin omega t. So this is E is equals to E naught sin omega t. This is plus and minus, where I is a total current flowing through this parallel resonance. Now this is act as a junction. So ये junction की तरह act करेगा, तो यहाँ आने के बाद में current दो हिस्सों में divide हो जाएगा. So this is IL, current across inductor. It means that IL is a current flowing through the inductor, and this is your IC. IC is a current flowing through this capacitor. Again there is one junction. So at this point IL is coming and IC is also coming. So that's how from this I is current flowing through this circuit again. So now this is a parallel combination, and in parallel combination हम लोग को पता है कि parallel combination में voltage same होता है and there is division of current. इसके previous वाले step में हम लोग ने series resonance देखा था. Series resonance में हम लोग series connection में there is a changing of EMF या changing of voltage, but there is a same current flowing through each components. Now, so this is a parallel connection. So due to this parallel connection, so this is EL, this is EL is EMF across inductor, and EC, so where EC is EMF across capacitor. Due to this parallel combination, this should be same, and this should be equals to this value, because this is alternating EMF is connected across this parallel combination. So we can write here, due to parallel combination, this all three are same. So this is E is equals to EL is equals to EC, which is nothing but E naught sin omega t. If I am putting sin omega t, it should be 1. E should be equals to EL, should be equals to EC, should be equals to E naught. So where E naught is peak value of EMF and EC is the EMF across capacitor. This is EL should be EMF across inductor, and E should be a induced EMF, that induced EMF due to change in the magnetic field or magnetic flux according to the Faraday's laws of electromagnetic induction. So E is equals to EL is equals to EC is equals to E naught sin omega. Clear? Now this is inductor and this is capacitor. So according to the phasor state for resistance and phasor state for inductance, phasor state for capacitance. So phasor state for resistance is EMF and current are in the same phase. Phasor state for inductance, EMF is lead by pi by 2 to the current, or current is lag by pi by 2 to the EMF. Yeah, in capacitor, the phasor state for capacitor, current is lead by pi by 2 to the EMF, and EMF is lag by pi by 2 to the current. So now according to the phasor state, so we are taking this equation. So EL should be equals to E naught sin omega t. Again EC should be equals to E naught sin omega t. Clear? Again E is that is E naught sin omega t. But if I am taking for equation of currents, so there is a deflection of current. Current is the lead in terms of inductance, current is lag by pi by 2. In terms of capacitor, current is lead by pi by 2. So that's why we are taking two equations for the current. So IL current across inductor IL. In inductor, the current is lagged by pi by 2 to the EMF. That's why your equation becomes this is I naught sine, this is omega t minus this is pi by 2. Why this is minus pi by 2? Because this is inductor, and in inductor the current is lagged by pi by 2 to the EMF. So that's why IL is equals to E naught sine omega t minus pi by 2. Now for the capacitor, so again we are taking that is IC. IC is equals to I naught sine, in capacitor current is lead by pi by 2. That's why this is sine omega t plus pi by 2. So this is the equation for IC. Now this is current, total current flowing through the circuits, and it is divided into two parts. So we take the equation from this one. So if I am taking the equation from this term, so it is called as total current. So I should be equals to IL plus IC. So this is the total current flowing through the circuit, and this is IL plus IC. We have the equation for IL and we have the equation for IC. So again, I should be equals to, I is equals to, this is what is IL. So we have the equation for IL. So I naught sine omega t, this is minus pi by 2, plus I naught, again this is sine omega t plus this is pi by 2. Clear? But this is peak value of current, and this is peak value of current for inductors, and this is a peak value of current, this is for capacitor. So again according to the Ohm's law is I into R, this is for I naught. तो अगर मैं यहाँ अगर XL और XC के चीज में बदलूं तो it is XL. So from this equation we get the I naught, equation for I naught is equals to E naught divided by XL. Again is equals to E naught is equals to, again in terms of capacitive reactance, so this is XC. So I naught is equals to, this is E naught divided by XC. So these are this equation for again I naught. This is peak value of current across inductor, this is peak value of current across capacitor. So put all these terms here, so we get I is equals to, this is E naught divided by XL, and this is sine omega t minus pi by 2, and this is plus E naught divided by XC. Again this is sine omega t, this is plus pi by 2. So we are using a trigonometric formulas. It's very simple. Sine omega t minus pi by 2, it's a minus cos omega t. So I is equals to, this is E naught divided by XL. This term is replaced by minus cos omega t plus E naught divided by XC. So this term is as it is, and this replaced by cos omega t according to the trigonometric functions. So if I am replacing this value, so interchanging this value, so this is E naught divided by XC cos omega t, this is again minus, this is E naught divided by XL, this is cos omega t. If I am taking E naught cos omega t common from here, so I is equals to E naught, this is cos omega t get common, what remains, this is 1 upon XC, and this is minus 1 upon XL. Clear? So these are this equation. If I am putting 1 upon XC minus 1 upon XL is 0, so this terms is 0, this is cos 0 is 1, and value of I is equals to E naught. So we get the equation for I is equals to E naught if 1 upon XL, 1 upon XC minus 1 upon XL is equals to 0. So if I am putting 1 upon XL minus 1, so here I is equals to E naught, and if we are putting 1 upon XC minus 1 upon XL is equals to 0. So this total term is 0, so that's why I is equals to E naught. So this Z is become maximum. So if your Z is become maximum, so your impedance is maximum, and when there is impedance of maximum, again according to the Ohm's law, if I am getting relation between Z and I, so impedance and current के बीच में relation लूँ, so यहाँ current is inversely proportional to impedance हो जाएगा, and when the current is inversely proportional to impedance, and if Z is maximum, so current is, but obvious it's minimum. So current is again minimum, and 1 upon Z is your admittance, again 1 upon Z is admittance, and 1 upon Z is your admittance, so Z is maximum, but obvious the admittance is minimum. तो आपका यहाँ से admittance क्या हो जाएगा? Minimum. So the value of admittance, so admittance is minimum. आपका एडमिटेंस मिनिमम हो जाएगा एंड रेजोनेंस ऑकर्स ओनली व्हेन, सो वी आर पुटिंग 1 upon xc minus 1 upon xl is equals to 0, so 1 upon xc minus 1 upon xl is equals to 0. So again we say that कि हमारा रेजोनेंस कब ऑकर्ड होगा, so from this relation 1 upon xc minus 1 upon xl is equals to 0, so 1 upon xc is equals to 1 upon xl. ये माइनस वाली टर्म इधर आ जाएगी, प्लस हो जाएगी, सो अगेन 1 upon xc, so ओमेगा c is equals to 1 upon omega l. So because 1 upon xc, the value of xc should be 1 upon omega c and xl is equals to omega l. So capacitive reactance and these are the inductive reactance. So again this is from this equation, omega square is equals to 1 upon lc, so omega is equals to 1 upon under root of lc. So omega is nothing but your 2 pi f. 2 pi f is equals to 1 upon under root of LC, and again this is f, and we are solving for parallel resonance. So f for parallel resonance, मतलब frequency for parallel resonance is equals to 1 upon 2 pi under root of LC. So this is the equation for frequency in parallel resonance. ये frequency हो जाएगी parallel resonance के लिए. Now we are taking the graphical representation again from this one. जैसे हम लोग ने सीरीज कॉम्बिनेशन में लिया था, हम लोग ने सीरीज रेजोनेंस में लिया था, सो अभी हम लोग लेंगे अगेन ग्राफिकल रिप्रेजेंटेशन. सो ग्राफिकल रिप्रेजेंटेशन, सो ग्राफिकल रिप्रेजेंटेशन फॉर सीरीज कॉम्बिनेशन, फॉर पैरेलल कॉम्बिनेशन. सो योर करंट इज मिनिमम, यहाँ आपका करंट कितना है, मिनिमम है. सो व्हेन योर करंट इज मिनिमम, so see here, because Z is maximum, impedance is maximum, your current is minimum, and when your current is minimum, so graphical representation again we see that. So this is your x-axis, this is your y-axis. We are taking current in the y-axis, so they are taking I naught. So I naught should be a current, and there is a frequency, and this frequency is your f suffix p. So frequency आपकी f suffix p हो जाएगी, because we are taking for parallel resonance, and for parallel resonance the current is your minimum, and for minimum current, so it starts from maximum, and it is like this. So this is your minimum current, so this is your I minimum. So the current is minimum, and this is a graphical representation for parallel resonance. Why this is a graphical representation for parallel resonance? Because the current, from this above equations we say that the current is minimum, and when the current is minimum, so we get the inverted graph, and this is I minimum. Clear? Now if I am talking about the characteristics of this one, so what are the characteristics? अगर मैं इसकी characteristic ले ले तो हम लोग क्या लेंगे characteristics? So what are the characteristics? पहला तो वही हमारी characteristic होगी कि भैया resonance occurs only when XL should be equals to XC. So your XL is equals to XC. This is the first characteristic, and second characteristic, your Z is maximum, impedance is maximum, current is minimum, and admittance is again your minimum. And when your admittance is minimum, so these are the second characteristic of this one. And what is our third? Yeah, this is inductive and this is capacitive, so that is XL should be is equals to XC, and this your third characteristic is कि यहाँ फिर से जैसे हम लोग ने सीरीज रेजोनेंस में बोला था कि this receiving only the frequency of maximum current, so it again rejecting the frequency of maximum current, so that's why this is called as a rejector circuit. इसको हम लोग rejector circuit कहते हैं. Why? Because why we called as this is rejector circuit? Because this circuit which is receiving those frequency which is have a minimum current, and it is reject all the frequency of maximum current, so that's why this is called as a rejector circuit. That's why this term is called as a rejector circuit. Why it is called as rejector circuit? Because it receive the frequency of a minimum current and it reject all the frequencies of maximum current. So when it reject the frequency of maximum current, so that's why it is called as the rejector circuit. And this is altogether the concept of a parallel resonance.